All right, let's take a second look at an example that uses the double cyclic technique of level 4 integration by parts. Here we have the product of two cosine functions. One is cosine 3x, one is cosine 2x. And we're going to use integration by parts to do this particular problem, so let's get started. We're going to pick a u and we're going to pick a dv. This is going to be our integration by parts round 1. And there's not much to do in the way of choosing here. So cosine 3x, cosine 2x, and we'll just get started. du is negative 3 sine 3x, and v is 1/2 sine 2x, and this becomes uv, which is 1/2 cosine 3x sine 2x, minus the integral of v du, which is going to be negative 3/2 sine 3x sine 2x dx. And if we clean that up just a little bit, we get 1/2 cosine 3x sine 2x plus 3/2 the integral sine 3x sine 2x dx. Now, in terms of basic integration by parts here, when we traded out our integrals, here this was about the same. So we haven't done any real damage, so we're going to do integration by parts again. So in our second round, integration by parts round 2, we'll pick a u, and I'll try to be as consistent as I can. They're both the same trig function, but in terms of consistency here, I'm going to go with the fact that my trig function for u had the 3x in it, so I'll have sine 3x here, in which case dv will be the sine 2x dx, since we had chosen the 2x to go with the dv. So du is 3 cosine 3x, and v is 1/2 cosine 2x negative. I'm kind of running out of room there. Let me move this over just a little bit. It's getting kind of crowded. Negative 1/2 cosine 2x. In this round of integration by parts, I get 1/2 cosine 3x sine 2x plus 3/2, and then I'll throw some parentheses in here. And this will be uv negative 1/2 cosine 2x sine 3x minus the integral of negative 3/2 cosine 3x cosine 2x dx. And if we clean this up, oops, and parentheses, this is 1/2 cosine 3x sine 2x minus 3/4 cosine 2x sine 3x. Let's see, this is going to be a double negative, so that'll be a positive 3/2 times another positive 3/2 will be a positive 9/4 the integral of cosine 3x cosine 2x dx. And what we now have is, let's see here, save a little bit of time here. This integral is this result. I don't know if I have enough room to do that. I guess I'll have to shrink this guy down a little bit. Scale it down. Bring it over. Oops. Scale it down a little bit. Just a little bit. So there's our result. And now what we can do here is bring this over so we can actually see what's going on. What we're going to do is we're going to use algebra at this point. We have arrived at the same integral on both sides. And so with a little bit of sleight of hand and some algebra here, we'll subtract 9/4 the cosine of 3x, cosine of 2x dx from both sides. And doing some quick arithmetic here, this is one of those integrals. Minus 9/4 is going to give us negative 5/4. The integral cosine 3x cosine 2x dx is equal to 1/2 cosine 3x sine 2x minus 3/4 cosine 2x sine 3x. Now those aren't like terms. Please note that these angles are not the same. We can't just combine those into a single like term. But what we can do is multiply both sides by negative 4/5, so that this is the integral of the cosine 3x cosine 2x dx is equal to negative 2/5 cosine 3x sine 2x plus 3/5 cosine 2x sine 3x. Now, even though we didn't technically integrate, we used algebra, don't forget that the general form of the antiderivative should have plus an arbitrary constant on the end. And that is going to be our answer. Whoa. There it is. That's our antiderivative. Now, that was doing this integral with integration by parts. There's actually easier ways to do this, and I say easier with quotes around it, air quotes, right? Because that's actually subjective. Aside. This is the secret. Shh. Be quiet. Don't tell anybody. Did you know that the cosine of alpha times the cosine of beta is equal to 1/2 the cosine of alpha minus beta plus the cosine of alpha plus beta, which means that the integral of the cosine 3x cosine 2x dx is 1/2 the integral of the cosine of 3x minus 2x, which is just x, plus the cosine of 3x plus 2x, which is 5x. And because that's a sum, it's just a super easy integral. Shebang. Now, I should say this. It doesn't look anything like the one above. But that's okay. The reason it doesn't look like anything up above is because we use a trig identity. So these are equivalent trig forms. Looks like I wrote farms there. They're equivalent trig farms. Anyhow, that's it for this video, and that's it for integration by parts. So, what are some other things you're expected to do? Besides level 1, 2, 3, and 4 integration by parts, throughout Chapter 7, you're going to be expected to go back and do other applications like volumes by rotation, volumes by cross-section, work, and some of those other applications. But now the integrals that result in those setups could use something like integration by parts. So you might not see a work problem per se on your second exam dealing with Chapter 7, but you will probably see a work problem on the final exam that uses an advanced integration technique. So I'm going to be combining some of these ideas on the final. So make sure you're reviewing as you go and look for some of those problems that are volumes and things like that, applications throughout Chapter 7. Okay.